Good morning everyone. Today we will discuss all the formulas of chapter 1 and chapter name is solution. Okay. So it is the modified expression. Here we will use Van 't Hoff factor. Okay. How we can use Van 't Hoff factor which is represented by I in all the formulas. Okay. So this formula it is given for RLVP. What is RLVP? Relative lowering in vapor pressure, that we have done already. Okay, so how we can use I here, that I will explain you. So I means it is the Van 't Hoff factor, and when we will use, it is used only for the electrolyte. Okay, if you are using the electrolyte, then only you can use it. But in case of non-electrolyte, no need of I. Okay, where you can put I is equal to 1. But in board exam they can ask what is the value of I if the solution is non-electrolyte, then you can write I is equal to 1. Okay, but if it is electrolyte, if it is electrolytic solution, then you have to put the values. If complete dissociation take place, okay, or complete association take place, then you can write value of I according to that solution. So you can see here expression is given for RLVP, that is P naught minus P1 divided by P1 naught. Okay. So what is given here? P1 naught. It is the vapor pressure of the pure solvent. And what is there? P1. It is the vapor pressure of the solution. Okay. So we have done this expression. So whenever you are taking electrolyte, you have to write the value, write Van 't Hoff factor in with mole fraction. Okay, and this is mole fraction, but it is used for the dilute solution. What is mole fraction? If you are writing mole fraction of any solute or solvent, suppose you are writing for the solute, 2 number you will give, and N2 divided by N1 plus N2. Okay, here the moles of both solute and solvent you have taken, but if solution is dilute, then moles of solute you can negligible, then expression will be N2 by N1 only. Okay, so this only given here. Okay, so we are revising all the formulas. Okay, in between the chapter we have done. Now here all the formulas written together. So you can see next it is elevation in boiling point. Delta TB is equal to KBM. We have done, but you have to use here I. Okay, so wherever the moles will come, in which term moles will come, there you can attach I value. Okay, so M, it is the molality. In molality moles it is coming here, so you can attach I with that. Above, in above expression also we have done this, means in mole fraction moles of solute it is coming here, that's why you have attached the I. Okay, so this is the expression for elevation in boiling point. In the same way you can write I value for the depression in freezing point. Okay, and here I you have attached because molarity is given, in which moles of solute it is given. Okay, osmotic pressure of the solution, it is equal to pi is equal to CRT. So you can see here C, it is the concentration in terms of molarity. It is not molality, it is molarity. Okay, and you know all very well, in molarity also moles of the solute it is coming, that's why you have to attach I with that. Okay, so I, where you will use wherever the moles of solute will come. Okay, so that you can show whether association or dissociation take place. Okay, so you can see here mass percentage. Okay, we are revising here, take care this thing. Okay, we have done already. Mass percentage, whenever you want to calculate whatever mass percentage of solute or solvent, depends on you, of whose you want to solve, that you have to keep upside. Okay, suppose you want to solve the mass percentage of solute, then WB you will write upside, because WB is the mass of the solute. Okay, divided by total mass of the solution into 100, because it is given here percentage, and volume percentage V by V, volume of that solute divided by total into 100. Okay, mass by volume, then given mass upside you will write, and then volume into 100, because it is percentage given here. Okay, parts per million. Okay, parts per million you are using for the very few particles that is present in excess thing. Okay, suppose you want to calculate the dust particle, or you want to solve the pollution level, okay, in atmosphere, in air. So air, it is present in excess quantity. So parts per million, it is the mass of the solid divided by total mass of the mixture into 10 to the power 6, because it is given here na million. Next, the term mole fraction, it is given. Mole fraction, if you want to solve, so mole fraction means actually how much quantity, how much moles of solute or solvent present in a mixture, that is called the mole fraction. Okay, so of which you want to solve, that you have to keep upside and total down. In the same way, of B, if you want to solve, then moles of the B upside, then total down. Okay, and mole fraction of each fraction, okay, moles fraction of each component, you can say, must be equal to 1. It is always equal to 1. If you are writing a XA plus XB, then it is always equal to 1. Okay, if you have taken the 3 component in a mixture, then sum of all the mole fractions of the component is equal to 1. Suppose 3 component, what you have taken? A, XB plus XC. Okay, in a mixture it is present na all 3 components, then always it is equal to 1. It is never more than 1. Okay, so molarity, it is given. We have discussed molarity means moles of solute divided by volume of solution in liter. This unit you have to take care. Downside, whatever you are taking, it should be in SI unit only. Okay, you can't take in ml. If you are taking in ml, then you have to multiply with 1000. Okay, then molality. Okay, in molarity and molality, what is common here? What are the things that is common here? Moles of solute up. Here also moles of solute given. Why? Because in both terms moles are coming. Okay, in molarity, volume of solution written here. Okay, in molality, this is the mistake here. It's not a volume, it is the mass. Mass of solvent in kilogram. Okay, here you can see here SI unit, it is kept here. If you are taking in gram, then you have to multiply with 1000. This is given in gram. Your next term, it is given here, normality. Okay, what is normality? In molarity and molality, we have taken the moles of solute, but in normality, you will take the gram equivalent weight of the solute divided by volume of solution in liter. Okay, so gram equivalent weight, it is equal to molar mass of the solute, given mass of the solute divided by molar mass of the solute. Okay, so you can write like this: gram equivalent weight is equal to given mass divided by molar mass into n factor. Okay, into n factor. Why you have written this? Because I will write here again. Gram equivalent weight. Okay, how you can learn? You can keep in your mind like this. Okay, so gram, it is coming upside, then you can write given mass upside, equivalent weight down. Okay, so given mass divided by equivalent weight, it is equal to molar mass divided by n factor. Okay, then n factor you can write upside. So actually gram equivalent weight is equal to given mass multiply n factor divided by molar mass. Okay, so this is the expression for gram equivalent weight. Okay, so gram equivalent weight we have written divided by volume of solution. You can put the values and you can get the answer. Relationship between molarity and normality. What is the relation? It is very, very important. Okay, normality is equal to molarity into n factor. Okay, this is the relation of normality and molarity. Okay, but you can connect the normality with molarity by this way also. Normality into equivalent mass always equal to molarity into molar mass. Okay, suppose normality given to you, you can use you can calculate the molarity by this way also. Okay, Now relationship between molarity and mass percentage. Okay, molarity, it is equal to P, it is mass percentage. Mass percentage means suppose it is given to you 10% W by V. So how much quantity of solute present here? 10 gram in 100. Okay, this is the mass percentage. So what 10 value you can put here. Okay, D, what is here? It is the density, multiply 10 divided by molar mass of the solute. Okay, so by this way you can solve directly the molarity. In other method also you can solve by using different methods, but this is the direct formula. In the same way, normality you can use P into D into 10 divided by equivalent mass. In case of molarity we are using the molar mass, but in case of normality we are using the equivalent mass. And we have discussed already, equivalent mass is equal to molar mass by n factor. Okay. Next formula is dilution formula. If you are diluting the any solution, in that moles of the solute always remains constant. Moles, okay, not a molarity. Moles I told. So for dilution, you can use the formula M1V1 is equal to M2V2. If you have made any solution of M1 molarity of definite volume, then after dilution the molarity will change. Then it will becomes equal to M2. So you can use this formula in terms of molarity. In the similar way for normality you can use N1V1 is equal to N2V2. Okay. In terms of normality it is. So molarity of mixture. How you can solve? Molarity of mixture means if you have taken the two solution A and B. If you want to mix, okay, after mixing then molarity will change. Okay. So how you can solve? Then different molarity you will get, it is represented by M3. It is M1 and this is M2. So M1 plus M2 is equal to M3. Okay. So in what form you can write here? By using a volume. Okay. So you can see here M1V1 plus M2V2 is equal to M3V3. Okay. So molarity it will change after mixing the two solution, but volume it is the addition effect. It is the addition term. Here V3 you can use V1 plus V2. Okay. So whenever you are adding the two solution, definitely it will add. Suppose you have taken 20 ml plus 30 ml, then it will be the 50 ml. So that volume you can keep here. Okay, V3. So by using this formula you can solve the molarity of the mixture. So how you can write this? M3 is equal to M1V1 plus M2V2 divided by V3. Is that clear to all? So this is the expression. So here little mistake is there. So instead of this you can write here this formula. Again I will write here this M1V1 plus M2V2 is equal to M3V3. Okay. So M3 is equal to M1V1 plus M2V2 divided by V3. Okay. Here V3 is equal to V1 plus V2. Now you can see here Raoult's law for the volatile solute. Okay. Partial pressure of that component must be equal to vapor pressure in pure state multiply with mole fraction. Okay. Now Raoult's law for non-volatile solute. Okay. That we have done. It is RLVP. Okay. In Van 't Hoff factor also we have used. So P naught minus P is divided by P naught. Okay. It is the vapor pressure of pure solvent. This is the vapor pressure of solution. Always equal to the mole fraction of the solute. Elevation in boiling point, it is delta TB is equal to KB into M. Okay. Osmotic pressure, it is equal to pi is equal to CRT. Okay. Van 't Hoff factor we have done. In terms of molar mass, you can write normal molar mass divided by abnormal molar mass. Okay. And I, you can write here total number of moles of the particle after association divided by total number of moles of particles that you have taken initially. Okay. So these all are the terms which we have written in terms of modified form by using a Van 't Hoff factor. Okay. So today only we have discussed already all formulas. Okay. And this formula, it is for degree of dissociation or degree of association. So again I will write here for degree of dissociation, I is equal to 1 minus alpha plus alpha n. It is what degree of dissociation. I is equal to 1 minus alpha plus alpha by n. It is for degree of association. Okay. Next one, you can see here Van 't Hoff factor. Okay. It is equal to 1. Okay. If you will take the non-electrolyte. Okay. And if it is complete dissociation or association will take place, then you can put the values of I according to the number of ions formed. Suppose NaCl you have taken, then I becomes equal to 2. Okay. How many ions are formed? 2. Then I will be equal to 2. If dimerization take place, then I, you can keep here, it is 1 by 2. If trimerization is take place here, suppose trimerization means 3 molecules has attached together. Okay. Then I will be equal to 1 by 3. Okay. So in this way you can put the values and you can calculate the question. Okay. So we have done, we have revised all the formulas. Here your chapter will completed. Okay. So next time we will do the numericals problem. So related to all these formula, you have to learn all the formula, then only you can solve the numerical. Thank you and have a nice day.